All right, so how you guys doing today? Doing good? Ready for test? Perfect. So because we're gonna have an exam next week, week from today for Wednesday group, and the Friday groups we'll have next Friday. So it'll be 19th of February. For Wednesday, it'll be 17th of February. Okay. So yeah, that is what we've been doing. I don't know if you guys watching the YouTube channel videos. We've been doing a review session from last week. Well, let's do this again today. Okay. So maybe we can try this one, okay? So this is maybe one of the potential problems you may see on the exam, or something like this one. Okay, so I'll give you about 2 minutes. Can you guys balance this one? Okay, about 2 minutes. Let's try it. We'll do this together. Don't worry about it. But let's try to balance this one first. Okay, so the point is to try to get the same numbers of carbon, hydrogen, oxygen on the left and the right side, okay? And see, yeah, sorry, yeah. So you can balance the equation. Okay, just 1 minute now. Okay, try. We'll do this together, and I want you to try first. Okay, so try this one first and see what we can do. Okay, 30 seconds. We'll do this together. All right, so whenever we try to balance the chemical equation over here, you can always start with the number 1 here. Okay? This is the one that has carbon and hydrogen here. So you can try the 1 first, okay? Which put 1 over here. But if you look at this chemical formula right here, each organic compound has 7 carbons and 14 hydrogen here. So to make the same numbers of a carbon, this one has to be 7 at least. Because even one organic compound will have 7 carbons here, but each carbon dioxide has only 1 carbon in it. So to make the same numbers of carbon, it has to be at least 7. Makes sense, right? And then same here, this is hydrogen 14, but each water has 2 hydrogen over here. So to make the 14 on this side, you can have 7, perfect, 7. So 7 times 2 is 14 as we're here. So now you do have a 14 hydrogen and 7 carbon over here. And let's do the numbering the oxygen over here. So we have 2 oxygen in each carbon dioxide. So 7 times 2 is 14 oxygen over here. We have only 1 oxygen in 1 water. So it'll be 7 water makes 7 oxygen in it. So in total, we have 21 oxygen on the right side. So to make the same oxygen numbers on here, this is the way you can find the oxygen. So it'll be 21 oxygen here. But as we explained before in previous lecture, the oxygen will be in diatomic molecule. So whenever you do this, there will be 1 oxygen gas molecule have 2 oxygen atoms. So to make 21 over here, you can do 21 over 2. So that makes 21 oxygen on this side too. So this is one way you can do this. But if you don't want to do fractional number, like 21 over 2, you can always do multiply by the denominator. So it'll be 2 here, right? So if you just multiply all of that 2, so 1 times 2 is 2. And 1 times 20 over 21 over 2 is 21. And 7 times is 14. And the 14 as well. Okay. So the number you're looking for is now 2, 21, 14, and 14. Make sense, right? Good? Okay. All right, perfect. Can I move on? Okay, let's move on. So if I ask you this in the exam, you need to find the 2, 21, 14, 14. That is your answer in the multiple choice question. Okay, the next one. Okay, next one is if you have a 0.041417 moles of C3H8 propane gas molecule, how many hydrogen atoms are there? Okay, I'll give you about 2 minutes or 3 minutes. So you have a 0.0417 moles of propane. Then how many hydrogen atoms are there? That's the question. So the one thing you need to know is 1 mole is what? Avogadro number, right? Avogadro number. That is equal to 6.022 times 10 to the 23rd. Okay, I'll give you about 2 minutes. So. Okay, 1 minute. By the way, you can bring your calculator on exam, but make sure you bring a really cheap one. Okay? Do not bring the really expensive one. I will not let you use it. Just buy the very cheap calculator. All right. So here's the thing. If you look at the chemical formula of the propane over here, each propane has 8 hydrogen over here. So that means if you have a 1 propane, you automatically have what? 8 hydrogens over there already, right? So meaning if you have this many moles of this one, is the 8 times this number in moles is the numbers of the hydrogen. But we know the 1 mole is equal to Avogadro number. So what we can do is 0.0417 moles. But each propane has 8 hydrogen over, right? So you can multiply that. There's numbers in propane, right? But it has 8 hydrogen here. So hydrogen wise, 8 times 1 propane, right? So you can multiply this number by 8 over 1, which is just 8. Okay? And then what? Now you have how many moles of hydrogen atoms now? But we know this is 1 mole. So you can multiply this number by 6.00022 10 to 23rd per mole. But this is how many per 1 mole. Okay? So then you have the answer right there. Okay. So that should be about 7.53 times 10 to 22nd. Hydrogen atoms. Am I right? Can you do this in the calculator? You can double check. But mainly you can just do this number multiplied by 8 and multiplied by the 6.22 times 10 to 20. This Avogadro number. Okay. Make sense, right? You good? Makes sense? Okay, perfect. All right. Next one. Okay, so if you have propane again, interact with this one. Okay. And then you have 25 grams of propane over here, and you have lots of oxygen over here. So if you have all 25 grams of propane used up, okay, and then how many grams of the carbon dioxide will be produced? That's the question. So you have 25 grams of the propane here, and it will be all used up because you have lots of oxygen, so there will be abundant reactants here. This will be your limiting. And then how many grams of carbon dioxide will be produced? That's the question. Okay. I'll give you about 5 minutes. This is a quite long process, so I'll give you 5 minutes. So try your best to solve the problem, but we're gonna do this together, so don't worry about it. Just try to find out your answer and try to compare the ones together. So it will make more sense whenever you try this one first and try it again with us, okay? This is a long process, so I'll give you 5 minutes. So the first thing what you need to do is balance. You need to balance the equation first. It's not 1, 1, 1, 1, as you know. So you need to balance this one first. Then you'll be able to use the stoichiometry there. So it's a long process. This might be the most difficult one in exam 1. So if you can get this one right, that'll be very good.
How many problems like that?
Just one, yeah. Because we only have 50 minutes to do the exam. So I promise you, I'm going to put one question like this. This takes about at least 5 minutes. So just one, just one question. Okay. Okay, so maybe one more minute and we can do this together. I know this takes quite a long time, but we'll do this together. Don't worry. Okay. All right, so let's do this together. So the once again, as we know, we kind of put this one of the reactants to oxygen gas molecule as abundant. So we don't have to worry about this one because it's the abundant one. But this is the one, obviously, the limiting the amount of the your products from this chemical reaction here. So we're gonna stick to this one here today. So we balance this one 1, 5, 3, 4 because I put 1 over here that makes 3 carbon dioxide and 4 water. So you can match up with the 3 carbons and 8 hydrogen there. If you do that, it's pretty much the same on the both side now. And also once I've done these two, you can have a 3 times 2, 4 times 1 that makes in total 10 oxygen here. So I put 5 because the diatomic molecule makes also 10 over here as well. Okay, makes sense, right? So this is now we have the coefficient numbers, and we all balance the equation over here, which means if you have a 1 propane interacting with 5 oxygen gas molecule, they'll produce 3 and 4 carbon dioxide and water. That's what it means. Okay, so let's try to do this. Use this one here. So always, if you do actual mass in grams divided by its molecular weight, which is in gram per mole. As you can see, the grams will cancel top and bottom, right? And you see there's the moles in denominator become numerator. So technically what it means that you'll get the numbers in moles now. So you'll be able to know how many moles of propane we have by just simply dividing your actual mass, which is 25 grams by its molecular weight. Okay? So then we need to find out molecular weight of this one to get the number in moles of this propane. So as we know, once again, on your exam, we'll have a periodic table. So you'll find the atomic mass of carbon and hydrogen on the periodic table. You don't have to memorize it, but we know it's about 12. And the hydrogen is about 1. Okay? But we have a 3 carbon, you have 8 hydrogen, so the 8 here. So if you do 12 times 3 is 36, plus 8 will be what? 44. So it's 44 grams per mole. So it means that if you have 1 mole of propane, they'll weigh about 44 grams. That's what it means. Because you have 3 carbons and 8 hydrogen. But you have less than 44 grams, right? So obviously, you have less than 1 moles of propane here. But you want to make sure to how many moles you have. Just plug the numbers in. The actual mass is 25 grams. And I said molecular weight is 44 grams per mole. So if you have a calculator, could you guys tell me what number is here? So what is the 25 over 44? If you have a calculator, could you guys tell me? Is it point? Yes.
Around 0.57.
57. Thank you so much. So we have 25 grams over 44. So now we know how many moles of propane we have. Perfect. So then now we got the moles of this one. Like I said before, if we have a 1 goes in, we'll make 3 carbon dioxide and 4. So you starting from here to there and there. Okay. So technically, the moles of propane goes to here and here, right? So it'll be 3 over 1 will be the moles of carbon dioxide. Okay? And the moles of propane multiplied by 4 over 1 is a 4 over 1, 3 over 1 for carbon dioxide and water. That's what I did. Okay? Moles of water. But in this question, we only wanted for the carbon dioxide, so we just, this one, just stick to this one. So what I'm going to do is I'm going to copy this number right here, which is 0.57 moles of propane over here, and will be times by 3 over 1. So if you just triple this number, that will be approximately 1.7. Yeah, right? Yeah, perfect. Great. So now you have an actual moles of the carbon dioxide, right? You get perfect. And then here's another thing I want you to memorize. whenever you have a number in moles, you can just multiply by it's a molecular weight. Once again, it's in gram per mole, right? Okay. Then if you multiply by these two, so moles cancel. Okay, mole per mole cancel. You get a number in grams. So you know now finally how many grams you have. So 44. The molecular weight of the carbon dioxide is 44 because the carbon is 12, each oxygen is 16. So 6 times 2 is 32. 32 plus 12 is 44. So it's 44 grams per mole. So if you multiply this number by 44 grams per mole, there will be 70 something. So what's the number? Yeah, you have a calculator. 1.71 moles times 44 will be 74.8. Okay, so the makes sense, right? Is the so it's a long process, I know, but this is the something we can use with the limiting reactions here. So just one question like this will be on the exam. Okay? So make sure you guys practice this one. Okay. All right. See. Okay. Can I give you just slightly different one here? Mm-hmm. Oh yeah. So yeah, I'll give you a slightly different one over here. So let's make it a bit more easier for the calculation. Okay. So let's say we have a like maybe 44 grams over here. Okay. Okay. We have a 44 grams over here, and we have maybe here is 96 grams. Okay. No, I'm sorry. Yeah, 96. Okay, 96 grams over here, and then let's try to find out how many grams of water will be produced here at this time. So it's slightly different from the last one because we have both of those two extra mass number x for the propane and oxygen here, and just try to find out the limiting reagent first and stick to that one to get the moles of product will be produced, and multiply that number in moles by its molecular weight, which is 18 grams per mole. In this case, we're looking for water. Okay, this is also another 5 minutes. So just try to do your best, and then we can try to do this together. Okay, maybe 3 more minutes. Okay, 1 or 2 more minutes. Okay, 1 minute. All right, so how many moles do you have over here? How many moles? One, right? Perfect. Yeah, perfect. One. Great, one. And this one, 96 grams over 32 grams per mole. Because once again, this is a 16 but diatomic, so 32. Okay. So with that, it will be 3 more. Perfect. Great. 3 more. But the problem is here. Whenever you have a 1 propane, you need to have 5 oxygen gas molecule over here, not 3. But you have a 1 moles of propane right now, then you need to have 5, but you only have 3. So whenever you do this one, you have a 1 moles of propane. But you comparing this one to this one is 1 to 5, right? So you go from there to there, right? So be 5 over 1. So meaning, whenever you have a 1 mole of propane, you need to have 5 moles of oxygen gas molecule required. Okay? This is required for 1 mole of propane, but you only have 3. So you have less than what you need to have for 1 mole of propane. Meaning, this is your limiting reagent now. Before it was the limiting reagent, but now we have this one as a limiting agent now. Because you have less than what you need to have for this one. So this would limit the amount of the products. Okay, makes sense, right? So now we'll stick to oxygen now, not propane. So we don't have to worry about this one, but we'll stick to this one. Oh, I'm just gonna. But yeah. So anyway, you know what I mean, right? So if we do this one here, we have 3 moles of oxygen. But think about it. If you have a 5 oxygen gas molecule goes in, it will make 3 and 4 carbon dioxide and water. But we're looking for this one here. So we compare to like this, like 5 to the 4. So you have a 3 moles of oxygen here, but it goes from 5 to the 4, right? So times 4 over 5. Okay, 4 over 5. That makes the 12 over 5 moles of water will be produced. Makes sense, right? This is a ratio. Because the 5 goes in, there will be 4 water. That's why we're doing this way. Okay. So that is 2.4 moles, right? Okay, 2.4. So 2.4 moles of H2O multiplied by its molecular weight is 18 grams per mole. So 18 is simply, this is 1 times 2, because there's 2 hydrogen, and 1 oxygen is 16. So in total, it's 18 grams per mole. So 1 mole of water will weigh about 18 grams. But if you have not 1 mole, but you have a 2.4 moles of 18 over here, right? So that would be your answer. Okay. So what is 4.2 times 18? Can you guys do this for me? 2.4 times 18. What's the answer?
43.2.
44. What was that? 44?
43.2.
42. Perfect. Great. All right. Perfect. So, do you know why I asked you to get this number? The sig figs. So, do you see how many sig figs are here? 2.4. How many sig figs here? 2. Perfect. How many? 2. So your answer should have how many sig figs? 2. So you can say 43, that's okay. If you say 43.2, that's more accurate, but scientific, sig fig number wise, it's kind of weird. But I wouldn't do anything on this one. Don't worry about it. I'm just telling you. You know what I mean, right? So don't worry about this one. It's okay. I'm just telling you for your information. Anyway. So if it was here 3.00, it was a 2.40, 18.0, it could have been just right answer right there. Because 36, don't worry about it. I'm just saying this for your. But as long as you can get this number, you're good to do that. Let's do another one. So I know this is kind of a long process. I'll probably do this on Friday, okay? But let's move on to the next topic. So most likely the exam problem I normally put on exam 1 is like, what is matter? This is the first topic we discussed in this semester. What is matter? Do you guys remember the definition of it? Perfect space. Perfect. That was a very good answer. So any physical entity, we can say being, that has mass and also occupying some space. That is the definition of matter. This is something I don't normally miss on the exam 1 as a first question, because this is the start of the chemistry. So if I give you one example that is not matter, if you guys remember this, it's light. Light does not have mass. The photon, so the smallest unit of light is what we call photon. They don't carry the mass. It's mass free. So it's a good example that is not matter. Make sense, right? Good. Okay. So please remember this for the exam. Okay. All right. So we also talked about the 3 phases of matter. Okay. Right. Perfect. What are those? Because you got perfect. Solid, liquid, nice, and gas. Okay. So sometimes I make a bit of a tricky question using plasma, which is also another state of the matter. But for Gen Chem 1 chemistry wise, those 3 are good. So don't worry about the plasma. Okay. This is something you may see on the certain space of the universe, which is very high dense energy that makes kind of weird status of the matter, because they can really hold this electron much. So anyway, there's those 3. Okay, so remember those 3 states, so you can answer the 3 phases of matter. Okay. Okay, so if I say homogeneous mixture only contains one identical elements, and say if it's true or false. Homogeneous mixture would contain only identical elements. So you say if it's correct or incorrect. Okay. So yeah, what do you guys think? True. Oh yeah. So here's the thing. The first step, I know this is kind of a tricky because it's like a homogeneous means like same thing, right? But the point is here, mixture. Okay. So you can have identical elements if it's mixture. So homogeneous simply means what? They are all similar. Yeah, they're all mixed in the same ratio in all proportions of the mixture. So if you look at this part or this part, the 2 different elements are mixed in the same ratio. It's like you guys remember the example I gave you last time? If you try to put a certain amount of the sugar into the tea, you can make sweet tea, right? But if you taste the sweet tea in the first sip and the last sip, it will be same sweetness for sure, because there will be homogeneous mixture. So same amount of sugar will be mixed in the same amount of the tea or water molecule. So the sweetness you feel in the first to the end will be the same, but it's a slightly different because your brain will adapt to your sweetness in the tea, but technically speaking, same amount of sugar. So that makes the good example of homogeneous mixture. Make sense, right? So this is false. Okay, make sense, right? This is a mixture. Can I move on? Do you have no question, right? Okay. Alrighty. I know it's a long trip, but this is what we discussed before. Okay. So here's the in chemical reaction, or you can say chemical change. Chemical formula of reactants do not change. What do you guys think about this one? True or false? In chemical change or chemical reaction, chemical formula of reactants or its composition will not change. Do you think? Perfect.
Yeah.
Yes. It's false, right? Because you need to remember the chemical change and also another one. What was that? Physical change. So physical change does not change the chemical formula of the reactants or the original sample, because it only changes the status or state of matter. So, for example, if you try to break this chalk into two pieces like this, right? It's still the chalk, same composition. So it'll be physical change. Or if you boil the water, so you can put the water into vapor form, which is gas phase, that will be still physical change. But in chemical reactions, you can actually going to change the ID, the actual chemical formula of the reactants will be different in the product side. So that will make the change in the chemical formula of the reactants. That's chemical change. So your identity of the original sample, initial sample will be different at the end of chemical reactions. So that's the difference between physical change and chemical change. You guys remember this? You good? Right, perfect. All right, so it's fourth, right? All righty. Let's okay, so the polyatomic molecules are composed of two atoms. I should say, each polyatomic molecule is composed of two atoms. Is it false or no? True or false? What do you guys think? Do you guys remember polyatomic anion we discussed in the nomenclature of the acid, oxy acid? So here's the thing. The poly means many. So polyatomic means maybe more than 1, 2, 3, or 4, or 5, 6, but just some many numbers of something making a one molecule. Okay, here. So if it's made of the two atoms, like we know the O2, H2, F2, CO2, Br2, is all diatomic molecules, which is made of two atoms. But this is only one example of polyatomic molecules over here. Okay, so if you guys say this polyatomic molecules is always composed of two atoms, that will be false. Because it could be 2, but also 3 and 4 and 5. Okay, so that will make this statement not so correct. Okay, it could be wrong because the polyatomic means more than 1, but it doesn't have to be always 2. Okay, makes sense, right? So if I say diatomic molecule is a polyatomic molecule, then it's correct. That means 2. So 2 is also more than 1. So then it's true. Makes sense, right? Okay. Alrighty. I think we can have one more problem to go. Okay, so the one molecular compound is a molecule. True or false? So we are asking for definition of a compound and molecule now, okay? So this, okay, let's do this together. So this is the not so correct because oh no, I'm sorry. This is correct. This is correct because the molecule is the broader concept. So compound is one type of molecule. Compound is one type of molecule. So if I say molecular compound is a molecule, that's absolutely right because this is a broader concept. Okay, but if I say the molecule is always compound, it's wrong because you're putting the smaller one on the top now. So the compound is the one type of molecule. So the molecular compound is molecule is yes. But if I say molecule is a molecular compound, no. It could be, but not always. Make sense, right? Okay. So that is correct. This is correct. Compound is a molecule for sure. The compound is one type of molecule. Okay. So I will stop here today. So.